right, so here's our calendar. Today we are going to do more factoring, and we're going to talk about products of binomials. Nothing coming up in the near future, but quest number 4 followed by test number 2 is a little ways away. Looks like right around Thanksgiving is when those two things are happening. Any questions on the calendar? Okay. So here we are with our daily summary. In this lesson, we learned how to factor the difference of two squares. Let's start by multiplying out a couple of products. Let's do this first one. X plus 3 times x minus 3. So I'll do the lobster claw thing here. You could also think of it as FOIL, or you could draw a box if you want to. Let's do this here. So when I multiply the first times the first, that's the x times the x, that's x squared. When I do the outer ones, that's x times negative 3, or minus 3x. Inner ones is a positive 3x, and the last 3 times negative 3 is minus 9. And what happens when we combine like terms there? We just get x squared minus 9. Right? The minus 3x and the plus 3x cancel perfectly. Why did they cancel perfectly? Well, these two things in the parentheses were exactly the same, except one had a plus and one had a minus. And that's why one of these 3x's was a plus and the other one was a minus. Let's take a look at this next one. Again, we'll do our lobster claw kind of thing. So first times first, that's 49. Outers is a positive 7y. Inners is a negative 7y, look at that, and then the last is a minus y squared. So if we combine like terms, again, we see things canceling in the middle, and we just get 49 minus y squared. And let's do one more. So here when I do the first times the first, I get 4x squared. Carefully here when we do the outers, I see negative 10xy. You with me? Negative 10 times xy. And when I look at the inners, I see positive 10 times xy. Those are going to cancel. And then finally, the last is a negative 25y squared. So if we cancel those two guys in the middle, 4x squared minus 25y squared. Okay? Yeah, so here's what I want you to take away from this. Sure, if you have to multiply two things that have exactly this pattern, you could save yourself like 3 seconds by doing this shortcut. That's not what I'm after. What I'm after is the other direction. What I'm after is if I give you x squared minus 9, I want you to be able to immediately factor it and tell me x plus 3x minus 3. If I give you 49 minus y squared, I want you to be able to tell me, oh, that came from 7 plus y times 7 minus y. That's what I want. Okay, so the shortcut isn't about going left to right, which is what we just did. It's going the other direction. So here's our pattern. If you see a squared minus b squared, like x squared minus 9 or 49 minus y squared, one perfect square minus another perfect square. If you see that pattern, you can factor it into an a plus b times an a minus b. So let's go that direction with these examples right here. X squared minus 64. So here's our question. Here's our process to decide if we can use our new formula that's in the box. Are there two terms? Yes, x squared and 64. Is it a difference, like a subtraction? Yes, it is. Are both of the terms perfect squares? X squared and 64. Are they both perfect squares? Yes. If the answer to all three of those questions is yes, we get to use our difference of two squares formula. In fact, that is the list of 3 questions. Is it a difference? Is it two terms? Is it perfect squares? Those are the questions. And so we say, hey, this is equal to 2 parentheses. The things that I'm going to write in the first slots have to be the same as each other, and they have to multiply to x squared. Okay, that feels like x times x. The things I put in the last 2 slots have to multiply to 64. But they have to be the same as each other. So you can't do 2 times 32. What do we have to do? Two things that multiply to 64, but they have to be the same. 8 and 8, right? And the formula says 1 plus, looking at this a plus b, a minus b business. 1 plus, 1 minus, and it's done. Okay, let's try part B. I'll ask the same three questions. Is it two terms? Yes. Is it a difference? Yes. Are they both perfect squares? Is 100 a perfect square? It is. Is a squared b squared a perfect square? It is. So we use our formula. The first two things that I put in here have to multiply to 100, but they have to be the same as each other. So what are they? 10 and 10. You don't get to put any numbers that multiply to 100. You can't put 25 and 4. You have to put the same number twice. In the other slot, I need to put two things that multiply to a squared b squared. Don't write this because it's incorrect. If you multiply those, yeah, you get a squared b squared, but they aren't the same as each other. Our pattern is that they have to be copies of each other. So what are the two things that I'm going to put there? A, b on both. You see it? You multiply them, you get a squared b squared. That's what we want. What about the signs? 1 plus, 1 minus in either order. Okay, let's take a look at C. 3r squared minus 27. I'm going to go through my same routine. Is it two terms? Yes. Is it a difference? Yes. Are both terms perfect squares? No. 3 is not a perfect square. 27 is also not a perfect square. So we failed. We cannot use the difference of two squares formula. But we can do something even more basic, which is to first factor out the greatest common factor. So let's begin there. What goes into both terms? 3. So you put a 3, and you figure out what's left in the parentheses after factoring out that 3. So 3r squared leaves me an r squared. Copy the subtract. 27 came from 3 times what? 9. Okay, so this is equal to the 3r squared minus 27. But now I've got something new in the parentheses, something I hadn't had before. And so I'm going to go through my same routine. The thing in the parentheses, is it two terms? Is it a difference? Are they perfect squares? The answer is yes to all three of those. So the thing in the parentheses becomes two parentheses. R squared came from what first terms? R and R. 9 came from what two terms? Could put the same number twice and it multiplies to 9. 3 and 3. And the signs, always 1 plus and 1 minus. So that part right there, those two parentheses multiplied together to give me the r squared minus 9 that I had, but you can't leave off the 3. That 3 is there till the end, so don't forget it. Okay, let's take a look at part D. X squared plus 25. Is it two terms? Yes. Is it a difference? No. That's a sum. We're done. As soon as you get one no to any of these three questions, you're done. You cannot use the difference of squares formula. I'm going to write the correct answer here. Do you guys remember the fancy word? I think we saw it the other day, irreducible. Means cannot be factored. You cannot reduce that thing any farther. Now I'm going to write the typical wrong answer. Don't write this. But okay, x and x, that's going to give me the x squared. What's going to give me the 25? 5 and 5. Now, if you do 1 plus and 1 minus, then what do you get when you multiply the last terms together? Negative 25, which is not what you want. Okay, so then the natural thing to do is both plus. Okay, that gives you positive 25. And the first give you x squared, all good. What do you get for the outers? That's a 5x. What do you get for the inners? That's another 5x. And when you combine them, you get 10x. Well, that's unfortunate because we don't have a 10x. So that's not the right answer either. Okay? We see what makes that plus, like just destroy the pattern. We just can't do it. But I've said this before, I'm a big old meanie. And so on the test or the quiz, I'm going to give you, like if I didn't put a 25 there, if I made it 26, then you wouldn't even be tempted to do this difference of two squares, right? But I'm a big old meanie. And so of course I'm going to give you a perfect square there, give you the opportunity to use the formula when you're not allowed to. Okay, let's take a look at E, x to the 4 minus 16. We'll go through our same pattern. Two terms? Yes. Is it a difference? Yes. Are they both perfect squares? They are. So we're going to use our formula. Okay, x to the 4th. It's the first time we've seen it, but we're just looking to put two things in these first slots that are the same as each other that multiply to x to the 4th. What are those two things? X squared. Because when we multiply those, we add the powers and we get x to the 4. So that's good. How are we going to build the 16? 4 and 4. And the signs we said 1 plus and 1 minus. Now, oftentimes at this point in the problem, you're done. You just use your difference of two squares formula once and you're finished. But we do have some still somewhat complicated things in the parentheses. So it's our obligation to take a look and see if we can factor the things in the parentheses any farther. So let's look at just the x squared plus 4. I'm going to go through the same pattern. Is it two terms? Yes. Is it a difference? No. So that's the end of the game. It's a sum. We can't do anything with that. Let's move on to the x squared minus 4. Is it two terms? Yes. Is it a difference? Yes. Are they both perfect squares? Yes. So we can use the difference of two squares formula here. Okay. Two parentheses here. I'm going to highlight. This thing is what I'm putting right here. Okay. What are the first terms that give me x squared? X and x. How am I going to build the 4? 2 and 2. And the signs 1 plus, 1 minus. So the two yellow things are done. I've got like a telling space that I left in the front. What am I supposed to put in that space? The first one, the x squared plus 4. You can't forget it. Just because we can't go any farther with it doesn't mean you don't have to write it down. So that is copied right there. Any questions on that one? Okay, so it's a fairly simple formula to use, and after you've done a couple of them, you get really bored because there's not a whole heck of a lot going on there. But it's easy to forget this formula in the midst of lots of more complicated factoring like the kind we did last class. So a couple of observations. So this formula, difference of two squares, you can abbreviate it dots, difference of two squares. So the dots formula only applies when you have two terms separated by a subtraction, each of which is a perfect square. Those are the three questions we kept asking ourselves. You can't use the dots formula to factor a sum, or just stop right away and say irreducible. Sometimes you have to use the dots formula twice on the same expression, like in part E. We factored x to the 4th minus 16, and one of them was x squared minus 4, and that one got factored even farther using the dots formula again. Okay, next page. Let's see here. So actually, we're going to come back to this page in just a second. Let's go one page farther. Go to this one right here, 160. Okay, a very, very quick review of the complicated factoring technique we learned on Friday. You're going to do it a bunch again today. So we're going to factor 6x squared minus 11x minus 10. We've got this hopefully familiar looking 2x2 box with all the numbers in it. So 6x squared, where do we put that? That's where the 1 is. That's in the top left. Where does the minus 11x go? That's the sum, so put that down there. And then the minus 10. That goes in the 3, the bottom right box. Good. And then the rest of the blanks we have to fill in, we have to create them. So you put your first 3 things in those spots every time. The fourth thing to do is to multiply to find the product on that diagonal. So 6x squared times negative 10, that's negative 60x squared. And then we get to the hardest part of the process, and that's filling in the 2 blanks on the other diagonal. And the 2 blanks satisfy these 2 conditions. Their sum is negative 11x, and their product is negative 60x squared. And remember, we always start by focusing on one of these 2 and not the other, which is the one that we start thinking about. The sum or the product. It's the product. We always think about the product. There's a finite number of options for things that multiply to negative 60x squared, but there's infinitely many things that add up to negative 11x. So we focus on the product. Some students ask more of themselves than they need to by thinking that they should just be able to pull these 2 things out of a hat, like thinking about them simultaneously. For me, I just focus on the product. Negative 60x squared, you don't need to write this because they're all listed down here, but I'll just show you the thought process. So I'm just looking for things that multiply to negative 60x squared. For example, 1x and negative 60x. Or 2x and what to multiply to negative 60x squared? Negative 30x. Or 3x and negative 20x. Be careful with the signs. 4x and four goes into negative 60. How many times? Negative 15 times. That's good there. 5x goes in negative 12 times. 6x goes in. So we're just going systematically. But at some point, we don't have to go every single number. So for example, 7x does not go into negative 60x squared, right? 8x doesn't go in, 9x doesn't go in, 10x goes in. If I put 10x here, how many times does it go in? Negative 6. Is that the same as the one that I just wrote? No, it's different. The signs are on different numbers. And so I actually think we got a shortcut here. Now, once we've started repeating, but with the opposite signs, I think the other answers are just the same numbers, but with the opposite signs. So for example, that 12x, I think, is the next one. And then what's the next one after that? 15x. And then 20x. And then there's 2 more up above. I've run out of space, but anyway, a very systematic, orderly way to list them out. And then finally, I start considering the sum. I wanted things that added up to negative 11x, so I just go one at a time and ask myself what they add up to. For example, if I add these 2, I get negative 59x. That's not the winner. I wanted negative 11x. Anybody see the winner? 4 and negative 15. That adds up to negative 11x. Make sure that you pick the ones that add up to the right sign. If you add 15x and negative 4x, you get positive 11x, which is tempting, but not right. Got to make sure you get the right sign. Okay, so that means that we get to put in the 2 boxes, 4x and negative 15x. We can put them in either order, but let's all put them in the same order. I'll put a negative 15x up here and a positive 4x there. Okay, so that is the hardest part. But like I said, there's a systematic way to just write them all down and pick the winner based on the sum. Okay, the rest of this is pretty straightforward with a little bit of practice. Looking in the first row every time, what's the greatest common factor? So let's look at the numbers first, 6 and negative 15. 3 goes into both. And what else can I take out of both terms? X. So 3x is the greatest common factor in that first row. And remember, that's the only greatest common factor we're looking for. The rest of this is a matter of putting things on the outside so that we correctly build the things on the inside. So looking up here at the 7, whatever I put here is supposed to multiply by the 3x to give me the 6x squared. What do I have to put up there? 2x is good. And then we look at the 8. Whatever you put in the 8 is supposed to multiply by the 3x and give you that green negative 15x. What is it? Negative 5. And then looking at the 9. So the 9 is supposed to be coupled with the 2x that we wrote up at the top. So what do I put to build that 4x there? 2 is good. I'd rather you say one other word. What else do I want to write? Not just 2, but positive 2. Like putting those plus signs in, because you need a plus sign when you write it in the parentheses. So we might as well get in the habit of putting it out there. Okay, so I think that means we've got our answer. This thing right here equals 2 sets of parentheses, 2x minus 5 times 3x plus 2. That's why I like the plus. Okay, so that was our quick review of the factoring technique from Friday. And like I said, you're going to do a bunch of that in the activity today. But one other detail that we omitted on Friday. So here it is. Let's go back to number 5. Okay, so suppose that we start with this negative 6x squared minus 15x plus 36. And we make a 2x2 box. We're trying to factor that thing. So somebody has made this box over here. So first, do you buy, like, are the things in the right spots? Negative 6x squared, do you see that where you expect? Yeah, and then 36, you see that in the bottom right. Okay, now somebody's done all of the hard work because they came up with the positive 9x and the negative 24x, and those don't appear over there. But they better have the right sum and the right product. So let's see, what's the sum of those two things? That's negative 15x, right? Which is the correct sum. It's this thing in the middle. And then the product, well, we know that the product should be whatever negative 6 times 36 is. So I think that's negative 216x squared. And if you multiply 9x by negative 24x, you will also get negative 216x squared. So somebody has built the box. It's all done correctly. Let's go ahead and fill in the stuff on the outside of this box. So first row, what number goes into both? 3. And there's an x in both, so 3x is our greatest common factor in that first row. And then we'll look up here at the top, trying to build the negative 6x squared. What goes up here? Negative 2x is good. And then up here, I'm trying to build that 9x. So what do we put? Positive 3. I like that positive. It's there. And then the negative 24x is supposed to be from these two. So what do I put out here? What is it? Is it negative 12? Is that right? Positive 12, right? But you can check, like you can put negative 12 and then you can catch your mistake, right? Like that would have given you a positive 24x. Positive 12 is good. Okay, let's fill those things in over here. Negative 2x plus 3, and then 3x plus 12. Okay, so the question is, are we done? Now, normally, once you finish the big 2x2 box factoring process, you're done. It's all completed. But in this case, one of these things in the parentheses can be factored farther. Negative 2x plus 3 you can't do anything with. But what goes into both 3x and positive 12? 3 goes into both. And so it is, again, our obligation to factor as far as possible. So let's write this, negative 2x plus 3. And then you factor a 3 out of the 3x plus 12 and get an x plus 4. You see that? 3 comes out, leaving x plus 4. This answer is correct. It's full credit. More common would be to put the 3 in the very front of the whole thing. Okay, so what does this mean? It means after you do the 2x2 box, you still have to check and make sure that the greatest common factor of the things in your parentheses is 1. So this is just one more thing to worry about. Well, no, not really. This only comes if you don't follow my advice from the beginning. So let me tell you the 3 factoring methods we've seen, and then the order you should apply them, and what the person who did up there did wrong. Okay, step number 1. Here's the order in which you should look to factor every single time. Step 1, always factor out the greatest common factor first. Before you do anything else, before you think about dots or a 2x2 box, you factor the greatest common factor first. Number 2, see if you can use the difference of 2 squares formula. That's our same routine. Is it 2 terms? Is it a difference? Are they perfect squares? And then number 3, finally try a 2x2 box if it looks like our standard trinomial that we've seen a bunch on Friday. Right? That is the order in which you should do things. So if we go back up and look at this problem up here, again, what's the first kind of factoring we should look for every time? Is the greatest common factor. So look up here, negative 16x squared minus 15x plus 36. What is the greatest common factor? 3. 3. So let's pull out the 3. What's left from the negative 6x squared? Okay. And then the minus 15x. Oh, this should have been squared, right? Negative 5x there. And then, I think that's a plus 12, right? 3 times 12 is 36. So this is what the person should have done first. They should have factored that 3 out. And then the thing in the parentheses, is it a difference of 2 squares? Is it 2 terms? No. So it's definitely not a difference of 2 squares. So then the only thing left in our toolkit is the 2x2 box method. And so you would do the 2x2 box method on just the thing in the parentheses, not on the original, which is what this person did when they filled in the box for us, but just on the thing in the parentheses. And if you did the 2x2 box on just the thing in the parentheses, you would get this right here. You get exactly the right thing, but with a 3 sitting in the front. And you wouldn't have to worry about like this extra step at the end of the process. Oh, is there a greatest common factor in either of my parentheses? There never will be, as long as you follow my advice, which is to factor out the greatest common factor first. One other benefit of factoring out that GCF first is that what does it do to all of the numbers? It makes them smaller. I just kind of told you that negative 6 times 36 was negative 216, but if you didn't know that, then all right, fine, you do the long multiplication by hand or you grab a calculator, but either way, then you're looking for factors of negative 216. Well, that's kind of annoying, but if you do a 2x2 box here with the much smaller numbers, that's a negative 2x squared there, that's a plus 12 there. What's the product? Negative 24x squared. I would much rather hunt around for factors of negative 24 than factors of negative 216. I'm assuming you're with me on that. So factor out the greatest common factor first. It has the added benefit of making all of the numbers smaller. Okay? All right, so keep the order in mind, those 3 things. Work here on this activity. I have given you plenty of boxes, but that doesn't mean you need to use the box on every single example. Go through the process in the order that I said. Don't feel like you have to do a box. I just copied and pasted them throughout in case you need them, but you should not need them on every single problem.